In this video, we are going to work with linear functions and try to identify them based on their shape and any tables or equations that we are given for these functions. So first, we need to make sure we remember what a function is. Then we're going to look at some pictures to see, is this a linear function? And then we're going to work with some tables and some equations. So let's get started. Let's take a look at our first graph over here. Notice that we have a line. Generally, a linear equation or a linear function graphs out to be a straight line. So the fact that we have a straight line, it is going from left to right, and it is changing over time. It starts up high and then it drops down low. This would be a linear function. So this is yes, linear function. And something to help you remember what a linear function looks like when you graph it is linear equals line. But that does not mean all graphs that are a line are going to be a linear function, but that is one of the ways that we can first help to decide, could it be a linear function? So let's take a look at the second one. Look at our graph here. It is not a straight line, it is a U shape, it is a parabola. So because that this does not have a line, it is not linear, this is not a linear function. Not a linear function. Okay. Then our last two, over here and down here, they look pretty similar. But here we have to take into account the definition of a function in order to decide, are these linear functions or not, because they are straight lines. So they fit that definition of linear. They are a line, but are they a function? So take a look at our first one up here. This has, let's just say, that point right there is x equals 3. Okay, so let's say we have a line going through x equals 3. Well, what is that point going to be? Let's say it is 3, 1. And then up here we have 3, 2. And down here I have 3, -1. Well, if I were to write the domain and range of this function, or of this line, I shouldn't call it a function yet, we haven't decided is it a function or not. If I were to write the domain and range, we hopefully notice that all of the domains, all of the x's, are the same. And the ranges change. So the fact that the domain is partnering with many different ranges tells us that this is not a function. This is not a linear function. There we go. So it is not a linear function because it is a straight line going up and down, and every point on that line has the same x value. Down here, we also have a straight line, but notice that it is going from left to right. So if I were to create a couple points on it, we'll call this 0, 2. We can call this -1, 2, and we can call this, 3, 2. Just some random points there. We'll take a look. If I want the domain and range of this line, my domain, my domain would be -1, or just these points. Let's pretend they're not connected, but we had -1, we got 0, we got 3. The range is 2, 2, 2. Everything has a partner, and it's okay for the range to be the same. It's not okay for the domain to be the same like we saw here. So this is a function. This is a linear function. So yes, linear function. So what are we looking for when we are looking at a graph? We're looking for a straight line, like we see here, here, and here, but we are also looking for the domain to not stay the same, for the domain to change. So here, the domain changes because our line is changing from left to right, it's going down, or it could go up. Here, the domain doesn't change because it's just a straight line on x equals 3. So this is not a linear function, but this is a linear function because the domain is changing from left to right, just not the range. So as long as the domain is changing, we are going to have a function. Alright, but what if they don't give us the graph? What if they give us a table? Let's see what we can do with a table. So here we have a table. We have our x values on the left, we have our y values on the right, and we want to use this table to help us decide, do we have a linear function or not? And the way we're going to do that is by comparing how our x's change and how our y's change. So first let's take a look at the x's. I start with 2, and then I go to 5. Well, I can get there by adding 3. Then I go from 5 to 8, which I added 3 as well. And then I go from 8 to 11 by adding 3 as well. So our x's are changing by the same amount. Now let's look at our y values. I'm starting off at 4 and I'm going to 3, so I am subtracting 1. Then I am starting at 3 and going to 2 by subtracting 1, and going from 2 to 1 by subtracting 1. And notice how all of my x's increased by the same amount, and all of my y's decreased by the same amount. Because these changes for the x's and the y's were the same, this is a linear function. Because in a linear function, your x and your y's are going to change at the same rate. Whatever's happening to your x's to change them, it's going to happen each time. And whatever's happening to your y's to change them, it's going to happen each time as well. And if it doesn't happen that way, then we do not have a linear function. So let's take a look at an example of a table where it is not a linear function. So let me erase these. And let's put our table up again. We got our x and our y. Let's go with negative 10, 10, negative 5, 4, 0, 2, and then 5, 0. Alright, look at our x's. On our x's, we're going from negative 10 to negative 5, so we're adding 5. Negative 5 to 0, so we are adding 5. And 0 to 5, so we're adding 5 here. Okay, so our x's look good right now. All the x's are changing by the same amount. But now let's look at our y values. We're going from 10 to 4, so we're subtracting 6. But then we're going from 4 to 2, meaning we're subtracting 2. And then we're going from 2 to 0, and we're subtracting 2 again. So even though these 3 points change by the same amount, that first one does not. So this is not a function, not a linear function. It could still be a function of some other kind, but it is not a linear function because it is not having the y's change by the same amount each time. Okay, so we have to be careful. All of our y values have to change by the same amount. All of our x values have to change by the same amount. Okay, we're doing pretty good so far. Lastly, let's talk about what the form of a linear equation generally looks like. Here is what the standard form of a linear equation looks like. You've got ax plus by equals c. and a and b cannot both be 0 at the same time. They all have to be real numbers, meaning they're not going to be imaginary, which we haven't talked about yet, but that is a thing. And in general, a should be positive in standard form, but we're not going to worry too much about that. So this is what the standard form of a linear equation looks like. If you see something that looks similar to this, you are going to have a linear equation which is going to be drawn like a line. Now there are some things that you need to notice about this equation. First, x and y do not have any exponents besides 1. We could write it as x to the first and y to the first, but no one does that. So we do not have any exponents on our variables. Second of all, notice what is happening between the x and the y values. You are not multiplying x with y, you are adding those values together. So you are not going to have any type of multiplication between x and y. And lastly, notice that there are no fractions here, but if there were, x and y would not be in the denominator. They would not be part of the divisor. They would be on top. They would be part of the numerator. So those are some important things to remember about these. And let's look at a couple examples where we want to decide, is the equation we're given a linear equation or not? So let's take a look. Here we have an equation that says y equals x plus 3. We want to first see, is this a linear equation? And to do that, we should try to see, can we change it into that linear equation standard form we just saw? And if we forgot what it looked like, remember it is, I'm not going to do it with all the colors right now, sorry, but it was ax plus by equals c. So let's take a look. I have to have my x and y on the same sides, so I got to get this x over to there. So I'm going to subtract x. That's going to give me negative x plus y equals 3. Okay, take a look at what we have here. X and y are being added together. A is a negative 1 because x is negative. B is a positive 1 because there's nothing in front of the y. And C is 3. This is a linear equation. And our standard form looks like this. Now we could, as I said, generally A should be positive. So if I wanted to multiply everything by a negative 1, I could change it into x minus y equals negative 3. And this would actually be the exact same line. This is the exact same equation. It is equivalent to the one in yellow. And it follows that rule that A should be positive. So there we go. Yes, this was a linear equation. Now let's try another one. Here we have the equation y equals x squared. Now take a moment and think to yourself, is this a linear equation? Can I write this as a plus, or sorry, not a plus, but ax plus by equals c? Can I write it like that? Well, I've got a couple issues as to why I can't. Can you think of any? First of all, x is being raised to some power other than 1. The fact that x is raised to the second power tells us automatically this is not a linear equation. And I can't really do anything to get rid of this without bringing in other things that would cause it to be a not linear equation, such as a radical. So this is not a linear function. We cannot write it like this. Okay, and that brings us to the end of our identifying linear functions videos. Hopefully you found this to be useful and you can now look at a graph and determine if it's a linear function. look at a table and determine if it describes a linear function, or look at an equation and decide can it be written in standard form to create a linear equation or not. Good luck.